Hello everyone. Today we have to learn about bigmmethod method, which is also known as penalty method or charne's method. To solve linear programming problems, we have to use this method. Let us solve sum number 1. Using penalty method, solve the following L.P.P. Objective function is given like this: minimize z is equal to 2x1 plus x2, and constraints are given subject to first constraint is 3x1 plus x2 is equal to 3. Second constraint is 4x1 plus 3x2 greater than or equal to 6, and third constraint is x1 plus 2x2 less than or equal to 3. And here decision variables x1 comma x2 are greater than or equal to 0. To solve this sum, in case of bigmmethod method, this objective function must be maximized type, and all constraints we have to convert in terms of equations. So to solve this sum, step number 1 is standard form. If constraint is having equal to sign like first constraint, then in that case we have to add artificial variable in that constraint. This is first constraint in which there is equal to sign, so we have to add here artificial variable a1. If there is greater than or equal to sign, then in that case we have to subtract slack variable sj and add artificial variable aj. Like in second constraint, there is greater than or equal to inequality, so in this case this is second constraint, so minus s2 plus artificial variable a2. And if suppose there is less than or equal to inequality, then add slack variable sk. Here third constraint is having less than or equal to inequality, so here we have to add slack variable s3. Let us find its standard form. Here objective function must be maximized type, and if it becomes maximized type, assign big penalty by subtracting mai and aj. So objective function can be written as maximize minus z is equal to z dash, because given objective function is minimized type, so we have to multiply both sides of objective function by minus 1. That gives minus z is equal to z dash, which is equal to minus 2x1 minus x2. And here first constraint is with equal to sign and second constraint is with greater than or equal to inequality. We have to add a1 in first constraint and a2 in second constraint. So big penalty we have to assign in objective function subtracting a1 and a2, subject to first constraint 3x1 plus x2 plus adding artificial variable a1 is equal to 3. In second constraint, we have to subtract slack variable s2 and add artificial variable a2. Hence 4x1 plus 3x2 minus s2 plus a2 is equal to 6. And then third constraint becomes third equation, x1 plus 2x2 plus s3 is equal to 3. Now considering objective function as equation number 1, first constraint as equation number 2, second constraint as equation number 3, and third constraint as equation number 4. In first constraint and second constraint we have added artificial variables a1 and a2. So we have to multiply second equation by third equation also by and add in objective equation. So z dash is equal to, here coefficient of x1 is minus 2 and here coefficient of x1 is 3, coefficient of x1 is 4, 2 and 3 are multiplied by so 3 plus 4 7 so minus 2 plus 7 x1. Then coefficient of x2 is 1 and here coefficient of x2 is 3, 1 times plus 3 times that is 4 and here coefficient of x2 is minus 1, so we can write plus minus 1 plus 4 x2, okay, and then minus s2, and then minus a1 minus a2, here multiplying a1 by a2 by so this can be written as plus minus plus times a1 and then minus plus a2. And from equation 2, if we take this 3 on this side and from equation number 3 take 6 on this side, then that becomes minus 6 and this becomes minus 3. Minus 3 times and minus 6 times addition minus 9 so we have to put here minus 9 okay, this becomes z dash. Now except this minus 9 take all terms on left hand side, then objective function becomes equation like this: z dash plus 2 minus 7 x1 plus 1 minus 4 x2 plus times s2 minus plus 0 plus 0 times a1 plus 0 times a2 is equal to keeping minus 9 on right hand side. Okay, this is objective equation. This is standard form. Now step number 2. In step number 2, we have to prepare simplex table like this. First column basic variables, second column decision variable x1, third column decision variable x2, fourth column slack variable s2, fifth column slack variable s3, sixth column artificial variable a1, seventh column artificial variable a2, eighth column right hand side constants, and ninth column for obtaining ratio. Okay, now here we have to put the coefficients of all these variables and right hand sides in this column from standard form. In standard form, objective equation is this one. Coefficient of x1 is 2 minus 7m, we have to put here. Coefficient of x2 is 1 minus 4m, put here. Coefficient of s2 is m, which we have to put here. Now s3 is not there, so its coefficient 0. a1 its coefficient is 0. a2 its coefficient is 0, and right hand side is minus 9m. Now next row, that is first constraint, which is equation number 2. Coefficient of x1 is 3, we have to put here. Coefficient of x2 is 1, put here, and here coefficient of a1 is 1. Coefficient of a1 is 1. Remaining coefficients of other variables, that we have to put 0, 0, 0. Right hand side is 3. Okay, now for second constraint, which is equation number 3, coefficient of x1 is 4, put here. Coefficient of x2 is 3, then coefficient of s2 is minus 1 here, then coefficient of a2 is plus 1, coefficient of a2 is plus 1, and right hand side is 6, and then coefficients of variables from constraint number 3, that is equation number 4. This is equation number 4. Coefficient of x1 is 1, put here. Coefficient of x2 is 2, then coefficient of s2 is not there, so 0. Coefficient of s3 is 1, put here. a1 a2 are not present in equation number 4, so 0, 0, and right hand side is 3. In this way, this is first table, or we can say 0th iteration. Okay, from this row we have to find out most negative number, so this is most negative number as compared to remaining, and this appears in x1 column, so x1 column becomes key column. We can represent by highlighting this. Now we have to find out key row. First of all, these right hand side elements we have to divide by key column elements. 3 divided by 3, that gives 1. In ratio column we have to put here. Then 6 divided by 4, that is 3 upon 2, and which is equal to 1.5. 3 upon 1 is equal to 3. From ratio column we have to find out least positive number. Least positive number is 1, so 1 appears in this row, so this row becomes key row. Okay, key row is highlighted. Now intersection of key column and key row, this number 3, this is key element, this is key column, this is key row. So replace a1 by x1 in next iteration. Okay, replace artificial variable a1 by decision variable x1 in next iteration, dividing each element from this key row by 3, dividing each element from key row by key element. Now simplex table for iteration number 1 by using values from iteration number 0. Key row, each element from key row is divided by 3. So 3 divided by 3, 1 divided by 3, 0 divided by 3, 0, 0 divided by 3, 0. And here A1 is outgoing variable. Okay, so this column A1 we have to keep it empty. There will be no change in this column from iteration 1 onwards. Key row elements are highlighted. Key column elements which are taken from 0th iteration are also highlighted. Now keeping remaining elements as it is, 1 minus 4m. Remaining all elements are written by pencil because we have to rough all these elements after calculation. Okay, key column element 2 minus 7m. We want here 0. This is equal to 1, this 0, and this 0 with respect to this element. So 3 upon 3, that is equal to 1. This is 1 upon 3. This is 0. This is 0. This is 0. And 3 upon 3 is 1. Okay, these are elements. Now with respect to this element, we have to reduce this element to 0. So opposite of this, that is minus 2 plus 7m into 1. We have to apply this operation. This we can write plus minus 2 plus 7m into this key row element 1. Now from this row, same operation we have to apply, plus into bracket minus 2 plus 7m into key row element. We can write here plus minus 2 plus 7m, keep this as it is, into key row element is 1 upon 3 here, plus minus 2 plus 7m into key row element is 0 here. In key row, this element is 0, so keeping this column as it is, like 0th iteration, m0 minus 1 0, m0 minus 1 0, as well as in key row this element is 0, so keeping this column as it is like 0th iteration, that is m0 minus 1 0, m0 minus 1 and 0 here. Okay, similarly this element is also 0 from key row, so this column also we have to keep it as it is, so you can put here 0 0 0 and this 1. Okay, means there is no change in these two columns, all elements will be like 0th iteration elements. Only we have to change this element, this and this, as well as this and this element. Okay, and then this element and this element. We have to reduce this element to 0 with respect to this one, as well as we have to reduce this element to 0 with respect to this one. So we can write here opposite of 4 is minus 4 into 1, that gives 0, and here also opposite of 1 is minus 1 into 1. Okay, then same operation we have to apply throughout this row. So here 1 minus 4m plus this element is as it is from 0th iteration, and then plus minus 2 plus 7m into this element. Okay, here also 0 plus we can write here minus 2 plus 7m into this element 0, then minus 9m plus minus 2 plus 7m into 1 into 1. Then from here operation we are applying like this, minus 4 into key row element, here also minus 4 into key row element is 1 upon 3. We are highlighting this column as well as this column because we are not doing any change in these two columns. So next element where we want change, this one, minus 4 into 0, this element, minus 4 into this element. Okay, now here in key column 1 minus 1 into key row element, minus 1 into key row element is 1 upon 3. Then here minus 1 into key row element is 0, minus 1 into key row element is 1. After calculation in first iteration we will get such type of values: 0 1 upon 3 minus 5m divided by 3, m 0 0 minus 2 minus 2m. Then this row 1 1 upon 3 0 0 0 1. Then this row 0 5 upon 3, this is minus 1 0 1 2, and here 0 5 upon 3 0 1 0 2. Okay, now we can rough the calculations we have done by using pencil. Rough the calculations which we have done by using calci. These are values from first iteration table. Now here in z dash row, in this row, most negative number 0, this and this, up to this only, most negative number is this one. Okay, and this appears in x2 column, so this becomes key column for next iteration. So we can highlight this. These are RHS elements 1, 2, 2. Divide these RHS elements by key column elements. 1 divided by 1 upon 3, 2 divided by 5 upon 3, 2 divided by 5 upon 3. 1 divided by 1 upon 3, this gives 3 in ratio column. 2 divided by 5 upon 3, this gives 6 upon 5. 2 divided by 5 upon 3, again 6 upon 5. Now from these three values we have to find out least positive value. 6 upon 5 and this 6 upon 5, both are same value. From these two you have to take any one as least positive value. Let us take this one, because in this row there is artificial variable. We can replace artificial variable by decision variable. For next iteration, A2 we are replacing by decision variable x2. So this is key row, we can highlight this key row and then we can move towards iteration number 2. This is key column, this is key row, and 5 upon 3, this element is key element. In next iteration what we have to do? We have to make this one, means divide this element by itself, and each element from this key row divide it by key element. Okay, and remaining elements you can put as it is like this. Each key row element from iteration number 1 is divided by key element 5 upon 3. So key row in next iteration, means in iteration number 2, that becomes 0 1 minus 3 upon 5 0 6 upon 5. Here artificial variable is outgoing variable, so column containing artificial variable A2 we have to keep it empty, and A1 also empty. So these columns are empty for iteration number 2. And now key column from iteration number 1 upon 3 minus 5m divided by 3 as it is. Its opposite, that will be minus of into bracket 1 upon 3 minus 5m divided by 3 into key row element 1. Then this 1 upon 3 as it is minus opposite of this minus 1 upon 3 into key row element. Then this element 5 upon 3 as it is minus 5 upon 3 into this 1. Okay. Same operation we have to apply for elements from this row, this operation, as well as this operation for elements from this row, this operation for elements from this row. Then this table becomes, in this key row, this element is 0. So you can take this column from this iteration, means from iteration number 1 as it is in iteration number 2 in next iteration. Same operation we have to apply throughout this row. Here minus of into bracket 1 upon 3 minus 5m divided by 3 into key row element. Here also minus into bracket 1 upon 3 minus 5m divided by 3 into key row element is here 0. Then here minus into bracket 1 upon 3 minus 5m divided by 3 into key row element is minus 3 upon 5. Then here minus 1 upon 3 minus 5m divided by 3 into key row element is 6 upon 5. As well as here also, in this row, throughout this row, apply this operation, minus 1 by 3 into key row element. Here also minus 1 upon 3 into key row element is 0. Then here minus 1 upon 3 into key row element is minus 3 upon 5. Then here minus 1 upon 3 into key row element is 6 upon 5. This as it is. Now here we have to apply minus 5 upon 3 into key row element. Minus 5 upon 3 into key row element is 0, minus 5 upon 3 into key row element is minus 3 upon 5, minus 5 upon 3 into key row element is 6 upon 5. Calculate this and get the values of this table. After doing calculations by using calculator, we get this row 0, 0, 1 upon 5, 0, and this minus 12 upon 5. Then this row becomes 1, 0, 0. We have to get this value minus minus plus 1 upon 5. So this will be 1 upon 5. And then this is 3 upon 5. This row 0, 1 minus 3 upon 5, 0, 6 upon 5. And this row 0, 0, 1, 1, this becomes 0. Okay, let us rough the calculations done by using pencil. Now here iteration number 2 is also completed. These are values from simplex table for iteration number 2. Now here in this row, in Z dash row, no one element is there which is most negative number. All are positive numbers. This is RHS value. Don't consider this one. Up to this only. All are positive values. So we can't find most negative number in this row. So we can't find key column and hence we can't find key row. Process stop here and now we can find the values of decision variables and then minimum value of Z. From this table, x1 is equal to, these are RHS values, x1 is equal to 3 upon 5. Then decision variable x2 is equal to RHS value 6 upon 5. Hence Z dash maximum is equal to minus 12 upon 5. Hence multiplying by minus sign, Z dash is equal to minus Z. Hence minus Z, that is Z minimum, is equal to, multiplying this by minus sign, 12 upon 5. Okay, so this is conclusion. Z minimum is 12 upon 5. This is solution. So let us stop here. Thank you. Thank you all. Thank you for watching this video. Thanks a lot.